Hello, hello all. In this session, we will see the different uses for a GIS. I mean the applications of the GIS. So the most powerful tool which to measure the hazards which is happening on the Earth surface, Earth crust. So we shall see the principles first and then we'll move on to the users. First one is principle of GIS, that is preparing the result, one of the most exciting aspects in the GIS technology, and also it is the variety of different ways in which the information can be presented, and also the database management and the update or data security will be integrity and the data storage and data maintenance abilities and geographic analysis, and the collected information is analyzed and interpreted qualitatively and quantitatively. So qualitatively and quantitatively both are important in the principle of GIS, and also the principal data capture the source mainly from the manual digitalization and scanning of aerial photographs or paper maps or existing the digital data sets. And also this GIS is something like we can make many jobs easier and faster and allow them to do more things and in the same space of time with the click of the a single button. And also it is surprising to many that this technology has been around over 50 years, and also the people because of this, people outside of the relevant fields and to some within fields who are just starting to learn about applications and potential of their work. And also it is still relatively new and existing with endless possibilities, and no longer the maps the exclusive preservation of the cartographer. Now urban and rural developers, medical sources, planners, conservation professionals, environmental agency staff to track and measure the flood plans, to measure the flood plans, that is e-hydrological or application of water or pollution control or soil, water and rough monitoring for the warning which is giving. For example, if there is any flood, before that we can see the some warning like the weather condition or the rain. So these are the measuring to see the geological applications on that. And also the utilities which is provided are just some of the environmentalist careers that can be benefited by this digital mapping. And how does this GIS works? That is for example, here I have taken two examples, simple examples. That is the first one, the fast food joint may look at maximizing their catchment area and accessibility. They will look at busiest roads, the best junction to place at, because whatever we are starting any business, so the first thing is we need to see the area and the catchment area and the accessible. For example, any business regarding with the cloths, so there we have to select very busiest road or near to any shopping centers, so that will be the exact the place to start the respective what to say business. So here I have taken the fast food restaurant kind of example. So definitely it will be very much closer to the any stations, railway stations or bus stations. So to calculate that catchment area, so definitely the GIS is going to helpful. This application of remote sensing, it will be very much useful. And also the restaurant will look primarily at the what facilities, the best facilities which reflect their image. So that is very important here. And even though they too will be concerned with maximizing their profit, definitely, so they may appear near to the any other restaurants, any theaters, the the crowded areas, so that everyone will visit, or they'll be visiting means if they want to purchase, definitely they'll purchase, or they'll be visiting and they're going. So we have to, the catchment area should be accessible. That area should be accessible. So this calculation also can be done by the GIS. So in the simple two examples I have taken here, and both may use GIS to find the ideal location, and also can be accessed to any number of websites to collect the relevant data for their business plan. And also in this respect, GIS is also kind of a problem solving using this geographic means, and this cooperative method of sharing pure and unbiased raw data has made it the ideal candidate and for everything that affects our environment, so or how our environment might affect us, so that and also we have to take it in account, and this information makes it easier to manage what we know and to explore what which is most useful to us in the basis of widest variety of relevant data. So, according to this GS and remote sensing, mainly it is going to useful for the catchment collection calculating. So for example, if you are considering any construction for a river catchment area, so definitely we have to use this remote sensing or a GS system for the measuring of the river, construction of any bridge across the river. So definitely we can't measure so easily. So accurately we can use a GS system or a remote sensing methods, and also length of the bridge. How much length and what is the height of the bridge. So these things and all we can easily calculate, and we can with images the GS will capture the details, and also from the, for example, dam areas. For example, anyhow we are constructing the dam across the rivers. So, so the dimension, length, width, the dimension of the dam. So definitely we can't measure uh, upon the river. So this GS system or remote sensing methods, definitely it is going to useful very much accurately to construct these huge structures, for example. And also one more example, that for example if you are constructing any highway, so that is also huge catchment area, so that we can't measure so easily. So definitely we can see where the trees should be cutted, or where the buildings or any the destructive object should be removed. So these and all we can definitely accurately we can measure from the GS system or remote sensing methods. And also any huge structure if we are taking, for example, the road construction is over, but we need to widen the road after some years. So in that case, so definitely we need to destroy few earth surface. I mean, earth's what to say. For example, trees or any buildings or any monuments or any important buildings. So definitely that measure, that is also can be easily we can measure by this remote sensing methods and geological this information system. So only not only this, for example, also seashore areas. To calculate the seashore areas is not, it's a huge catchment area. So there also we can be we are using the GS system and remote sensing method. And also the best example, which one more thing I wanted to give, the islands which is constructed on the water. So definitely on the water we can't measure any of the things. So the GS system, this is going to capture the images and going to send us. So definitely we can see the area to be what we have to construct on the water, so that according to the images which is captured by GS system or remote sensing methods, we can utilize that image for the construction or in the any other better way. Okay.